Hello guys, and welcome to another video. On this video we'll be looking at answering questions that are based on a transverse wave. So here they say that a transverse wave is generated by a string as shown in a picture below. It took 3 seconds for the wave to be completed. And when you look at this transverse wave, guys, we need to be able to tell how many waves are on this particular transverse wave. And we need to also remember what is it that makes up a wave. And what makes up a wave are two pulses, okay? If I have two pulses, they form one complete wave. So what you will notice here is that this pulse, let me just go back. So what you'll realize, let me highlight with this, what you'll realize is that this pulse is the first pulse, and then we have this pulse. So that means we have two pulses, and if we have two pulses, that means we're gonna have one wave. So if I have wave one, and then this side first pulse, second pulse, that's the second wave, and here I have these other pulses, and this means I have 1, 2, 3 waves. I hope guys you see that. So in this transverse wave I have 3 waves basically, okay? And then now we're gonna go to our questions. And I also guys want to inform you that this 1,5 is actually the distance from this point to this point. So the distance from up here to here is 1,5 meters. Now let's go to our questions. The first one says, for the given wave, write down the period. When we write down the period, guys, we need to firstly understand the definition of period. And the definition of period is the time taken for one complete wave pulse or cycle. Excuse me, the time taken for one complete wave or wave pulse or wave cycle. So this point up to here, that is one wave cycle, right? And if it took 3 wave cycles 3 seconds to travel, it means one wave cycle travels for 1 second. So the first wave 1 second, and when we have another wave there, it's gonna be 2 seconds, and when we have the third wave, it's gonna be 3 seconds. So the period is the time taken for one complete wave cycle. So one complete wave cycle is gonna take 1 second. So the period is going to be 1 second. All right, that's the answer that we'll have here. So the answer is going to be 1 second. And then we look at amplitude. They say for the given wave, we have to write down the amplitude of this wave. What is amplitude? By definition, amplitude is the maximum displacement of particles from their rest position. The displacement of particles from their rest position. And if I'm looking at where my particles are in terms of the rest position, this horizontal line, guys, is going to be my rest position. So my particles move from rest position. Excuse me, that my particles, guys, are gonna move from the rest position and they will reach the maximum point. They can move from here up to here, or they can move from here up to here. So my amplitude is the displacement of particles from their rest position. So the question is asking us, what is the amplitude on this transverse wave? What we'll see is that from this point to this point we have our amplitude, but the problem is that the distance we are given here is 1,5 meters, and 1,5 meters is the combination of the amplitude at the top and the amplitude at the bottom. But we do not want the whole distance. We want the distance from this point up until that point, not from here to here, because this 1,5 is from up here to here when we combine the two amplitudes. But we only want one amplitude, the size of one amplitude, and the size of one amplitude is from here to here. That means it has to be half of 1,5, because it's going to be from this point to this point, or from this point to this point. So that means we have to take 1,5 and divide it by 2. Okay, and if we do that, what is it that we get as our answer? The answer we are going to get, guys, when we divide 1,5 by 2 is 0,75 meters. So that is going to be our amplitude. Now we move on to the next question. The next question says, if the wave travels at 2 meters per second for 3 seconds, calculate the distance d. So they want us to find this distance. All right, they want us to find this distance. So what is this distance? Well, for us to find that distance, guys, and this question is for 2.2, what we are going to do is use the formula speed is equal to distance over time, but another person can use distance is equal to speed multiplied by time. That formula is also welcome. You can use speed is equal to distance over time, or distance is equal to speed multiplied by time. Okay, the one I'll use is the first one. My speed, guys, is this 2 meters per second. We know that speed is measured in meters per second, so I'm gonna write 2 here, and then the d is the distance which I've been asked to find. What about t? T is the time, and t is 3. In this case, we know that time is measured in seconds, so we know that this 3 is gonna be our t, and then from here we do cross multiplication. D multiplied by 1 is going to be d, then 2 multiplied by 3 is going to be 6, and our distance will therefore be 6 meters. Okay, and distance, guys, as you can see, is measured in meters. If we're using this formula, we would simply say speed multiplied by time, and it also give us 6 meters. I hope, guys, you see how that one works. This was 2.2. We were determining what? The distance d. Then we move on to the next question. The next question is 2.3. 2.3 wants us to find the wavelength. 2.3 wants us to find the wavelength. Before we find the wavelength, let's give the definition of wavelength. So wavelength, by definition, is the distance between two consecutive points which are in phase, or you can say it is the distance between two successive points that are in phase. And we can find our wavelength from here to here. We can find it here and here. We can find it from here to here. We can find it here and here. We can find it here and here. Okay, let me use different colors, in fact. So the wavelength can be here and here. We can also have it here and here. We can also have it here. So this point is the wavelength, this one is the wavelength. You can also find it here. So between these 2 points, every color that is the same, the wavelength is found between those 2 points. That's where we find our wavelength. Even here, guys, we can find our wavelength. Let me use yellow. Even here. So between all the highlighted points, that's where we find our wavelength. Here, 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 and we also can find it there. So that's where we find our wavelength. It is the distance between two consecutive or successive points that are in phase. That is the definition of wavelength. Now, in this case, when we find our wavelength, how are we going to find it? We are going to use this distance. Okay, how are we using this distance? It's because when you use that distance, you will realize that from this point to this point, we have the first wavelength. Then here and here we have the second wavelength. Then here and here we are going to have the third wavelength. Let me use this color. From here, here, and here we have the first wavelength, second wavelength, and the third wavelength. So it means we have to take this distance and divide it by the number of wavelengths. That is going to give us one wavelength. Okay, so the distance we are going to take and divide it by the total number of wavelengths. That's when the wavelength is not given. we take that distance, and that distance we found it. Remember, we just found the distance on 2.2. It was 6. Let me just write that this is wavelength. Wavelength is equal to our distance divided by the number of wavelengths. How many wavelengths do we have? We have 1, 2, 3. So it's 3. What is our distance? Our distance is 6 divided by 3. 6 divided by 3 is going to be what? It's going to be 2 meters. So our wavelength, guys, is 2 meters. I hope you understand how we work this one out. Let's move on to the next question. The next question, which is 2.4, says calculate the frequency of the wave. How do we calculate the frequency of the wave? We calculate frequency of the wave by using this formula, F is equal to 1 over T, or we can use the formula V is equal to F multiplied by lambda. Okay, any of these two formulas will help us to find the frequency. Let's start with this one. We are now doing 2.4, right? So with this one, for frequency, we need to know what is our period. But if you recall, we said our period is going to be 1 second, and it was here, right? So if our period is 1 second, it means I can substitute here by 1, and if I find my frequency, I'm simply gonna say 1 divided by 1, and I'm gonna get 1, and frequency is measured in hertz. Then if I use this formula, the second formula, you will remember that we have our speed. Our speed is this one here, right? Our speed is 2 meters per second is equal to frequency is what I'm looking for. Our wavelength is gonna be multiplied with frequency. What was our wavelength? It's the one that we just found here. Remember, we said the wavelength is equal to 2 meters. So I can substitute with 2 here, and then I will divide by 2 on both sides. If I do that, it means I'm gonna have frequency being equal to 1 hertz. So any of those two formulas will help you find your frequency. I hope you understood this, guys. Please hit me with a like and also subscribe if you have not. I'll see you on the next video. Thank you. Bye.